Okay, my clock is showing 2 o'clock Eastern time, so we will get a start here. Thanks everyone for joining. Um, you can see up in the top that this session is being recorded. That's so that we can share this information with the general public, those who couldn't be here today for this specific session. If you do not consent to being recorded, please do drop off this Teams call, and there is still an opportunity for you to ask questions by email if you choose not to to be recorded today. So we do want to welcome everyone for attending this new effort that we've had. We're calling it Office Hours for the FY 2023 CINR call. This is really trying to open up an opportunity to continue the conversation with the Office of Nuclear Energy Program Managers and to try to continue to create those connections with the university community. We do have Prasad here is our program manager, and Prasad, I'm not sure if John Orchard is planning on joining or if he's not. Are you taking all the questions?
I thought he was, but
okay.
He may be on travel too. So if not, we'll figure it out.
We'll hold. Yeah, we'll hold on here and see if he does join a little bit later. But I want to thank program managers for being here and for supporting this activity. There's really 3 main objectives here. The first is to help use the university community better understand ongoing programmatic activities. So please direct any questions you have about ongoing work at the lab or the broader DOE complex, or the labs, excuse me. Second is to receive clarifications about the now published scopes and what fits within any mission and what fits within the relevant topic areas. So any clarification questions you need to ask there. And overall, just to build a better communication network between universities and the programs. And so I hope this effort will help in that regard. To that extent, we'd ask that you limit your questions to the objectives of this meeting. I will remind everyone that since the scopes have changed quite significantly from years past, and that they are much more wide open, much more much more fit within each of the scope areas. That means that from a relevancy standpoint, the focus is more heavily focused around what fits within and meets DOE any mission. And the emphasis on program priority has been lessened, meaning that, of course, we encourage applications that support the programs in some way, but we also are intentionally allowing these to be broad for good, different ideas, innovative ideas from the university community to be able to be proposed in these scopes as well. So for that reason, you'll notice that each of these topic areas has an other scope area, meaning that if you feel the research that you'd like to propose doesn't really fit into the specific subtopic areas, that there is that other category that will allow you to propose something that may be outside of the current thinking with the subtopic areas that were written. From a logistical standpoint, we will take calls by using the raise hand function in Teams. If you're not familiar with Teams, you go to the reactions area, which is kind of in the middle of your screen at the top. It's a little smiley emoji with a high five on it, and you'll go and you'll click raise hand, which is right before that, right underneath that when you open the panel. We'll go in order of who raises their hand first. Would like to encourage you to ask as many questions as you need to, but to be respectful of the time. We have about an hour here, so we want to be respectful of the time and give everybody an opportunity to ask one or more questions. So just keep that in mind as you're interacting with Prasad and with other program management here. With that, I just want to introduce the topic areas really quickly that we'll be covering today. We split the fuel cycle section into 2 separate areas. We had our previous session yesterday. This is focused around the FC3 and FC4 subtopic areas. Those are on spent fuel and waste disposition, disposal research, which is what Prasad is leading here. And then spent fuel and waste disposition, storage, and transportation. John Orchard is our federal point of contact there. And I don't yet see him here on the meeting, which means we'll ask Prasad and other folks here from DOE to fill that gap as well as we can, and follow up with any questions that need additional response by email after this meeting. Once again, like I said, FC5, other fuel cycle technologies, it's more of an other catch-all. If you feel like the research you'd like to propose doesn't really fit well into the two areas that we're discussing today, it may fit well into that other area. So with that, Prasad, I don't know if you have any comments, any introductory comments that you'd like to make before we open up for questions, but I wanted to give you the floor to say anything you'd like, and then we'll open for questions.
Thanks, Drew. I don't really have anything to add, except that we have been in this program, which is FC3 and FC4, running now about 10 years or so. And we have stayed on what's generally called generic research in these areas of waste disposal and related storage and transportation. So to that degree, we have not have any site in particular. So site related activities will be very limited in discussion. So bear in mind that we are looking from a university perspective, some scientific new knowledge to be brought to the program in geosciences and others. And as you've seen in FC3 and FC4, we've tried to target a few more specific areas, and not that they are exclusive. In previous years, we have been generally leaving a whole lot of areas on. That still continues to be the case. And we will be looking, as Drew mentioned, much more wider latitude to seeing how these things can be addressed. Looking forward to your questions and comments.
Yep. Thank you for that, Prasad. We will we'll open up the question and answer period here. We have an hour. If we do answer some questions and the questions drop off and we're ready to make a final call for questions, I will do that. So we have up to an hour, but we'll kind of conclude when we've kind of answered all the questions and the meeting kind of goes silent in some space. So with that, please feel free to raise your hands and we'll call on you and get this started. Nathalie, go ahead.
Sorry, I had a hard time finding the mic this way. So for FC3, we are being asked to look at specifically the Sandia roadmap. And in the roadmap, there is a lot of language about radionuclide solubility. Do you consider radionuclide speciation being part of solubility?
Yeah, I would think some of it, because we are looking at over many decades, almost a million years in computing things. So you would find daughter products and others along the way. So we should be looking at additional speciation that might be relevant. So some softer characteristics of those. And I think you are working on some of that already. So you have a better idea how those things come together. I guess right now you're probably looking at iodine 129. So
yeah.
So there is at the end of the day, I think we have to make sure that what we are doing has a greater importance than a narrow research importance. It's got to support the performance characteristics. Whether something that happens, the software characteristics are so dominant that it has a relevancy with regard to the performance assessment. So because we are dealing with a lot of uncertainty in different parts of these things, and it's not always sure that one dominant uncertainty reduction would really make any difference in the overall performance assessment. And some of the staff people on this call, I gather, would have a good understanding of the particular radionuclide or its characteristics that are important to this thing. Now, you pointed out to the roadmap. Now, there are other, we have been putting out some 5-year plans. Every year we are updated. So they are also probably available in OSTI. You'll have to do a little searching for that. So it gives you a little more currency on where we are with going forward. Now, well, like Drew said, the important thing is that we have been focusing on a program. These are mostly labs driven, national lab driven. But then you guys can go outside the box and see if we are looking at, are we looking at relevant stuff that are important downstream? As universities, you have the opportunity to present your case that, yes, you address this in your 5-year plan or in your this thing, how important it is. You can make your arguments over and beyond what we have done. So feel free to do that. But as a point of reference, we have given you that the roadmap and other documents. And I would advise most of the folks on this call also to visit some of the documents we have put out for GDSA, that is the Geologic Disposal Safety Assessment. That's the computational aspects that gives you some insights into a lot of the processes we are looking at. There are reports coming out, and many of them are Sandia driven, or there is Berkeley and Lannel and Livermore, Argonne, and of course PNNL. So look for all those multiple reports that might give you some insights into where we are at. Thanks. Any other, Natalie, anything else?
Another thing was when you talk about geological barrier, are you interested in understanding the fundamental behavior of a geological barrier?
When you talk about barrier, are you meaning engineered or the natural barrier?
Either one.
Okay, well, in the engineered barriers, we have looked mostly because in the studies we have been looking at saturated, reducing type of environments. And there we have used mostly a bentonite-based backfill for engineered barriers. Now, for the natural barriers, we're looking at argillite or crystalline and salt, primarily, and some shades of shale and things like that. We are looking at it also. So when you look at these things, you have to be careful what the function of these barriers are. For instance, the engineered barriers are particularly sensitive to temperature considerations because that's closest to the waste form that's put out there, which is relatively hot. The spent fuel is relatively hot. So there are more processes in the engineered barriers as the heat drives some of the things, the geochemistry, the soft-2 characteristics and things of the bentonite. And then in the far field, you look at the disturbed zone effects and then go into the system, the longer transportation or retardation, whatever it may be in the natural system. Now, the natural system consists of multiple layers of other things too, or in crystalline case, you may have a fault that is predominantly a preferred pathway for radionuclide transport. So it's a system that we end up looking at. So focusing on one characteristic of one thing may compromise you on something else. So you got to be very careful that when you propose something, it is additive in performance, not detractive from some other parts of the performance. So keep that in mind.
Okay, thank you.
All right. We'll continue taking questions. Prasad's comment did make me think of something. As we're shifting into this area that is quite a bit more open, uh, it really does shift the burden onto all of you as the university community to make strong justifications for why the approach, the method, the research is impactful in that space. And so we're really looking for great ideas, but ideas that are also well justified. So that's a little bit of a change that happens as a result of opening the scopes up like this to allow for all sorts of ideas. So I see next we have Luis Ibarra. Go ahead.
Hi, good morning. This question is about FC4, and I'm reading at the call and looking at item 4 at the end of the description. Stresses and strains on fuel bundle components due to transportation or seismic loads. Are you still interested on seismic performance on storage facilities? Because that will seismic loads probably will have any effect on the fuel bundles.
Yeah, Luis, thanks for the question. We are doing, you are pretty aware of this probably, there's a lot of work being done on this. Actually, there's a shaker table test going on in Southern California on a program driven by Sandia. And trying to look at all and instrumented and seeing whether there is, you have all these transfer functions are adequately represented. So you're going to get some data out of those, a big, huge test. And I think you in the past also done some of those big scale modeling and some shaker table tests also.
Yes, correct.
And in that case, so what we are looking for is something we haven't considered. Some of these things tend to be almost design specific. We have done these things. There is finite element and everything else we have done over the past 30 years in earthquake engineering, and we've done an overall general good agreement with actual foundation testing and all that done. And so at this point in time, I would suggest follow some of the programs we are doing through Sandia and step outside the box and see if there is things that we can do better, something very uniquely research oriented that we haven't thought of. So I give you the latitude that way to come up with some of these things. These things, the issues of seismic and bundle behavior is important in the sense that we have to, in storage, it has a certain relevance. In if we are going to keep the container as is and put it in underground, that's a different story. But of course, the earthquake issues probably maybe a little less deep underground, depending on how you design the stuff. And except the shear of falls, that's a slightly different question from the shaker table stuff. So I would, because of your background, and I know what you've done before, I would encourage you to look at all these things, including what you've done, and see if there's an area that we would benefit in performance understanding it. We are all related finally to the performance of these things. And then, of course, as you know, one of the interesting things we want to make sure is the pellets don't crumble and create a potential criticality event eventually. So the integrity of these internals is important to us. So we are looking at different facets of it in a way that is there a simpler way of doing it, or is there a better than the conventional way we are doing it? So I agree with you. There is a lot of things done already. So
yeah, and going on.
Yeah, and going on too. So that's where I can't personally, because I've been involved in these things, and John has also been involved in all this, we may have come dry with ideas, probably. So it's about time somebody also took a fresh look, not from a conventional point of view, and see if there is added value of doing something different that will help the performance assessment of all of these things during storage, transportation, and hopefully in the disposal.
Sounds good. Well, thanks. So basically, all these new ideas still are part of FC4, not FC5. As long as they are related.
When it be called out under FC4, part of it is we are relating to a lot of the testing we are doing and everything else. So you can come in from the outside and say, hey, this is a better way to do something, or I'd like it to be research as opposed to engineering, okay? We got to be very careful that we don't just add if the science is already there, then heck, there may not be new things to do. I don't know. So giving you the opportunity to think beyond us.
Sounds good. Thank you, Prasad. And can I have a different question for FC3? This is about, again, issues like areas, knowledge areas. For example, they talk about which package failure modes. In this case, if something is considered for any of these points, can we consider it's better to put these potential failure mechanisms in a generic site, or are there specific sites that you would like to see for those type of mechanisms?
No, here's the thing. You have, I think, worked in the Yucca Mountain stuff, so you
Correct,
know.
yeah.
Well, that was a unsaturated oxidizing environment. Now, most of what we have been looking at is saturated reducing environment. So now, in this case, we are not going to pick and choose a particular metal container, or we are going to specify here's the geochemistry. But if you scan the entire work that's been done internationally and us, some of the chemistry parts could be, for either from Monterey or any of these things. Of course, in Yucca Mountain, it was J13, but that is irrelevant now in the sense that so you would have a span of geochemistries to deal with in saturated things. Now, what are the materials? Usually, some of them we think about normally steel. Now, the Swedes are using copper for that matter, or, they're different things. So again, the concept of containment is also different internationally. Some people say, okay, absolute containment, whereas in the US, we had looked at how a waste package would degrade with time, either by corrosion, by fracture, or by any creep rupture, or whatever the condition we pose on it. So it may be there's an opportunity for putting all of this in a perspective and a way to look at new science that we don't understand, particularly for long-term application, because it may be sitting there in a saturated condition, and the geochemistry may evolve in the near field, because the earlier it's a high temperature driven and different constituents show up, and later on it might be benign or flooded by something else. So you may have to make some assumptions, obviously, but if there is a new scientific way of figuring it out, most of the things we have done is electrochemistry driven for understanding material degradation with the geochemistry part of it. But then, collapse of different things. So it's not that we haven't done this in the past, but then is there something we have missed in looking at these things, or there's new technology that's in the horizon that upends the electrochemistry we have been doing, for that matter? Just is throwing something out there.
Yeah. Okay. Thank you.
All right, we'll continue taking questions over the course of the next 30 minutes or so here. So please do raise your hand if you have additional questions. While we have a little lull here, I do want to Anna will share in the chat some reminders about some resources that we do have available. Those include webinar presentations that happened about 6 weeks ago, both in video and PowerPoint format. A question and answer that came from that webinar, and this information from these sessions will be added to that question and answer. General question and answer from the NEUP website about the application and review process if you're unfamiliar with that. And finally, if you do have additional questions after this session concludes, please do reach out by email at neup@inl.gov, and we will process through those questions, get them out to program managers, national technical directors, or points of contact to be able to provide answers in a timely format for those. So I'm not seeing any additional questions here. I think at this point, with no additional questions, we'll call for final questions here. If anybody does have a final question, we'll do a final call. And Majdi, I see that you've raised your hand. Go ahead.
Thanks, Drew. Yeah, I probably should introduce myself here. So I'm a new assistant professor at the University of Michigan, Nuclear Engineering and Radiological Sciences. So I do have a question on FC3, the disposal. So actually 2 quick questions. The first one on post-closure criticality. So does the DOE is interested, or the office is now interested on more post-closure criticality? I saw it as a high priority in that CINR report, but I have seen a lot of work from Oak Ridge National Lab on post-closure criticality. I have done also some work on it as part of my PhD. So I'm wondering what aspects of post-closure criticality you are looking for as part of this proposal.
Yeah. Thanks, Majid. The thing we have been looking very more carefully is particularly with DPCs, dual purpose canister.
Mm-hmm.
And the idea behind that has been, this is the motivation for us. If we can dispose that directly underground, and dual purpose canister right now theoretically is both storage and transportation.
Yep.
But then we are moving into that. That's what Oak Ridge and Sandia have been working to see if there is any criticality consequences as a result of long-term storage or moving and stuff, and then what happens with it. So I think if you probably have been working in these areas where you, as a result of anything happening, like the fuel rods break down or the pellets fall in some configuration that might create a criticality. Now, in the Yucca Mountain days, most of what the regulations have talked about is keep it dry and keep it, no moderator effects. So that was one driving the probability of having anything wet around it. That was one of the issues. But whereas now, because we are looking at saturated conditions and reducing conditions, and in some cases, they may create situations that any critical configuration of the heap or the fuel elements might cause criticality. Now, what are the programs we've done with it? We've tried to see if they can put some inject in things inside the DPCs so it can be structurally safe. There have been some activity in that area from both, I think, Oak Ridge and PNNL and Sandia worked on that quite a bit. And the question is the integrity of those fillers too, and there have been many issues. So the question is not just how about calculations, but an integrated way of looking at how we can reduce the potentiality for criticality event. Now, also hand in hand is what if does happen some criticality event, what are the consequences? Is it a controlled event and just maintain a small, event that may just die off and not create a problem in changing the field environment. So that's where we are. It's the main driver was the dual purpose canister.
I see. Okay, thank you. And the second one is really on if there's a potential now for looking at the materials degradation of the DPCs for the office. So we're probably proposing or planning to propose something related to looking at the cask degradation because of the decay heat over long terms and kind of analyzing this phenomena related to stress corrosion cracking, or for example, when we expect the DPC would fail under certain decay heat levels. So are these types of materials analysis of interest to the office for this year call?
Yeah. Yes. Be careful about knowing if there's a marginal effect, it may not affect performance. So just be careful that when you explain why you want to do a certain thing, make sure it is performance related. How much difference does it make? Now, yes, it is good to understand certain things, and that has in itself some usefulness to the program to know what are the effects of these things. Now, some of the temperature ranges may not be at the state that it will, create creep effects on the plane, on the creep rupture or any of that kind of thing. The pressures are low too. So you got to go through a system analysis to see whatever you're proposing is of extreme value, good value to make the performance connection. So just because it is high temperature and this, and the design takes care of it, then there's not a whole lot you can do about it.
Yep.
So.
Thank you so much, Professor. I appreciate it. Thank you.
All right, this is our final call for questions. Do want to thank Prasad for taking the time and being here, giving this these detailed descriptions and answers to the questions. I'm not seeing any final hands here, so I'll go ahead and wrap up the session. Prasad, thank you for being here. As a reminder to all of you, due dates coming up for the CINR funding opportunity include an NSUF letter of intent if you're involved in that program. Submissions are due today, and we have our pre-application due date on October 11th, so coming up here in a few weeks. If you do have follow-on questions that come up after we conclude this session, like I said, submit those to nup@inl.gov. I would encourage you to do that early as you can. That way we can get those over to our program contacts, get some detailed answers back to you in a timely response so that you can actually use any of that input in preparation for your pre-applications. So once again, I would encourage you, I hope that you found this event informational, and would encourage you to provide any feedback back to our office, the university programs office here at the Office of Nuclear Energy to provide any feedback on these sessions and how we could improve them in the future. So Xinguang, I saw you just jumped on. We are just wrapping up the session. So if you do have a question, would like to give you an opportunity to do so before we all say goodbye.
Oh, okay, yeah. So I have a question on FC3. So we know actually the so-called vitrification is an important way to process or to immobilize the nuclear waste. And over the long-term time, and some helium cavities or some they will be formed in the nuclear waste. I wonder whether a study on this topic will be fit for FC3.
Prasad, you are muted.
Sorry,
Prasad.
I cannot hear you.
Yeah, Prasad, you're muted.
Okay, can you hear me now?
Yep.
Okay.
We can hear you now. Go ahead.
Oh, okay. I'm sorry, I muted it. I was thinking you could. Anyway, the vitrification, there's a lot of studies done on that, and obviously the work it's on vitrified glass is for the high-level waste, not the spent fuel, commercial spent fuel. Now, if you're going to be proposing anything, particularly make sure it is with the glass cavitation or anything else is significant enough to make a difference in performance. That would be important to consider. So we would like to see your arguments, what the integrity of those cavitations might be, or whether it breaks up the glass structure or it creates a new set of problems. Sure, we would like to hear from that, but make sure it is performance related. In other words, what does it do? It just changing the form a little bit. I mean, it doesn't affect the form, affect the performance. Then you should be, it may not pass muster.
I see. Okay, thank you very much.
All right, that concludes our topic area 2, FC3, FC4 area. Prasad, thank you once again for being here, and we will catch up with all of you later. Hope you all take care.
Bye.
Thank you, Drew Prasad. Bye.
Bye. Take care.
Thank you.